All right, so we're gonna talk about functions. So we've been talking this whole last 2 weeks or whatever we've been here for the semester about linear functions, nonlinear functions, kind of those patterns. Now we're gonna kind of pull it all together into functions, which is what we really talk about in algebra. So we have two sets of like specificity for things. So a relation is just anything that pairs numbers in the domain with numbers in the range. So these may or may not be a function, but they are going to be pairing numbers together. So we've talked a little bit about domain and range already, I think. Remember, domains are my inputs. We're usually talking about the x's, right? We generally write the domain inputs as x's. And the range is outputs of a function or a relation, so the y's. Right, so a relation is just anything that pairs numbers together, right? We get really specific and things we really care about are functions. So these are special relations where every value in the domain is paired with exactly one value in the range. So this gets where we get into really specifically talking about functions that each value in the domain only goes to one thing in the range. I apologize for these did not copy as well as I thought they would. Okay, so we have a few different ways of looking at telling if things are functions, right? We'll get to the vertical line test, which I think all of you have heard of. I've heard a lot of people reference it at different points. Another thing we look at is what's called a mapping diagram. So basically that takes my stuff. So from the domain, gives me domain and range. And the arrows just tell me what things like pair to each other. So -2, the output, when you put -2 in, the output you get is 0.5. 0, you get 2.5, and so on. So I have do not disturb on. What is happening? Okay, sorry. So when I want to tell if this is a function, I want to make sure that everything over here only goes to one thing over here, right? So does -2 only go to one thing in the range? Yeah. Alex, does 0 only go to one thing in the range? Yeah. 4, yep. 5. This is okay that they both go to 2.5, but because each of these only go to one thing, this one I can say yes is a function. So sometimes we'll look at where you just get a mapping diagram. It's just saying, is this a function or not? Other times, more like the second example, it'll give you a set of points and it wants to know if that set of points were graphed and a line was made, would it be a function? So kind of what's important to do is to look at this and say, so what here is my domain and range in each of these points? So remember, points go x, y. So if I want to list out my domain, I'm listing all of the x values, right? So like 6, 4, domain, all my x's, right? So I want to list those out. Not in red though. So 6, 4. Because I have 6 repeated again, I don't need to list that one a second time. I'm just going to list that once. And 5. Right, so there's my domain. I could fill that into my mapping diagram. So 6, 4, 5. It doesn't matter to me if these go in numerical order, right? If you see it on a test, it'll probably go like 4, 5, 6, just because that's what they do. I don't care, and it doesn't matter for what we're doing. So look at our range. Remember, those are our y's, right? So like our blue here. So I'm going to list those out and say, so I have 5, 3, 4, and 8. So when I make this mapping diagram, like if it says make the mapping diagram, I'm just gonna draw lines where things go to, right? So my first point was 6, 5. So I know 6 goes to 5. And I'm gonna keep that going. 4 goes to 3. Then I have that 6 goes to 4 again. And 5 goes to 8. So when I'm looking to see if something's a function, I'm looking to say, I want to make sure that everything in my domain only has one line going out of it. It doesn't, right? 6 has 2 going out. 6 goes to 5 and 6 goes to 4. So this one is not a function. All right. The easiest thing I think to check is if you have a graph and doing the vertical line test, right? So vertical line test says if vertical line passes through more than one point of the graph at a time, then it's not a function. So if I think about this, I wonder if I can. Okay, so if I think about vertical line test, right? I want to take a vertical line, so take a pencil, whatever, or imaginary one, right? And I'm going to take this, and I'm going to go through the graph and say, am I ever hitting more than one point on that line? Did I ever? No, right? So because I never hit more than one point, this is a function. All right, so I can keep doing that. I can look here and say, only one point, only one point, only one point. Just be careful that, like, when you get into this kind of section up here, your line's thicker, so it may look like you're going through more points, but you're not. So this one would be a function. All right, and I look at this last one, and I say, well, right away, I have a problem with here and here, right? So because I hit more than one point, this one, not a function. As y equals negative 3x plus 1, that's the same thing as f of x equals negative 3x plus 1. So just know that, like, y and f of x mean the same thing. And f of x just tells us what to put in for x. Right? If there's a number in that parentheses, it says like f of 2, it's telling us to put 2 in for x. So like if I looked at this example here, I could say, well, tell me that wx equals 250 times x. And that's the number of words you can read in x number of minutes. So how many can you read in 8 minutes? So if I wanted to write that out and say, well, what does that mean? Well, it wants to know what is W of 8. That's what I want to know, right? So now, instead of having x, I'm going to have 8. So we did 250 times 8. And then I just want to evaluate that. So W of 8 equals 2,000. So that would be all you're asking for there. That's just like evaluating expressions, which I think we've done a little bit of, maybe. All right, one last little practice. This kind of follows from what we did the other day with domain and range and like that kind of stuff. So it tells me that I have 3 quarts of paint to paint the trim in your house. A quart of paint covers 100 square feet, and it gives us this function. A of Q represents the area in square feet that Q quarts of paint live. So it wants to know what domain and range are reasonable for this function. So one thing about, is the domain going to be the amount of paint I use or the area I can cover? What am I changing? What am I putting into this? Any ideas? What do I control? The amount of paint I use or the trim I paint? Allison, you got any thoughts? The amount of paint, right? So the domain is amount of paint. And then the range is the amount covered. So I want to know what's reasonable, right? So for my domain, what's the least amount of paint I can use? Could I say, screw this, I'm not painting any trim because it's a pain? What? Yeah, right? I could say, I'm not going to use any paint, right? So to show you, one of the ways we'll write this is 0 is less than or equal to x. But what's the largest amount of paint that I can use? The largest amount of quarts of paint? Alex, what's the most quarts of paint that I can use? 3. So my domain has to be between 0 and 3. And then my range, they're kind of the same thing, right? If I paint no area, if I do use any paint, I'm going to have no paint used. And if I know this function tells me 100 times Q is the amount of area of paint, and if I know 3 is the most that I can paint, I plug that in to find the most area I can paint. So 3 times 100 would give me 300.